Okay, so we're given the head of two sorted linked lists, list one and list two. They want us to merge the two lists into one sorted list. And the list should be made by splicing together the nodes of the first two lists. So they want us to return the head of the merged linked list. So just looking at the example, what do they mean by merge two sorted lists? Well, we have list one here in red, list two here in purple, and they basically want they don't want us to create any new like list node uh, or anything like that. We're literally just shifting around the pointers and then returning a brand new list that is the combined list where the nodes values stay in ascending order, right? So a given node's next node cannot be less than itself, right? It's like every subsequent node in the list has to be equal to or greater than itself, right? So just it's just ascending, right? So we basically need some kind of algorithm to do this for us. Um, I will solve this using the iterative solution or one variation of an iterative solution. So let's just put a few list nodes down here. So we'll say we have like L1 here, and then we'll say we have, let's just do L2 here, and we'll keep this pretty short. So we basically need the very first thing we need to do is just check, okay, um, is list one empty? Is list two empty? Right? Because if list one and list two are empty, we can just return a null pointer. If list one is empty, we can return list two. If list two is empty, we can return list one, right? So it's basically those two cases to check before we get into the actual merge. Are both empty or is one of them empty? Because it's pretty straightforward what to do in those cases. Okay, if we get to the merge, we have to create a dummy node, right? So we have to create a new list pointer in memory, just a single one. So this will be constant space. We are going to keep track of this with a current pointer, right? So this is our L1 list pointer. It's pointing to the head of L1. This is our L2 pointer. It's pointing to the head node of L2. This is our current pointer or our combined, we'll say like combined pointer. This is pointing to the head of our dummy node. At first, we're also going to have a just a like a I'll say T for tracker to that's going to stay here because at the very end of this we will return T next or temp next. We'll have like this temporary pointer that just stays here and never moves. Otherwise we'll have to iterate this combined one down as we are building this. So basically what we'll do is we're first going to check, okay, is the node at L1 bigger? Because we're going to have a loop, right? Just backing up a second. We're going to have a loop at each step in our loop. Or even before that, we're going to loop while L1 and L2 are both not null, right? So while both L1 and L2 still have elements, we're going to loop. The first thing we'll do is we'll check which one is bigger. So L2 is bigger, so we want to add L1, right? So we're going to say current next is equal to the node of L1, right? Then we want to move L1 down the list. We want to move current down the list, okay? And then we repeat. So, okay, L1 and L2 both are not null, so we'll compare which one is smaller, L1. So we're going to add the node here at L1. So current next will be equal to this, pointing to this 2. Okay, then we're going to move L1 down the list. That becomes null. Notice we still have to move current down the list, or the combined. I keep mixing that up, but current combined, whatever. We're going to move this one down too. We're going to notice that L1 is null, so we're not going to loop anymore. There are two things that can be true at this point. Okay, either both L1 and L2 can be null, or only one of them might be null. If they're both null, we don't have to do anything. If one of them isn't null, then we have to preserve the rest of those elements, right? We have to do one more action, right? We're not done combining. So even though L1 is exhausted, we still have elements remaining, potentially many more elements of L2. So all we have to do is just one more time say current next is point that to whatever is the head of L2 at this point, right? Or vice versa for L1. So just that's like the final operation of the merge. Okay, and then we're basically at the very end of this, we can return whatever this temporary node pointer is pointing to, whatever its next pointer is pointing to, right? That's going to be the head of the combined list, right? So this would be the answer for those two lists that we had. And the time complexity is going to be, let's see, big O of n, where n is the number of elements in both lists. So like L1 plus L1.size plus L2.size equals n, right? It's asymptotically linearly bounded in time complexity, and then the space is just going to be constant. So we're not going to use any other data structures for the space. So yeah, let's get into this. So the first thing we want to do is we want to check if not list one, right? Then we can return list two. So we're just doing those checks, right? Before we do any kind of merging. Okay, is list one empty or is list two empty, right? So if they're both empty, right? And this would be totally okay, right? So if not list one, and also if not list one and not list two would be null pointer. So we'd return null pointer. That's totally fine. So we don't have to explicitly say like if not list two and if not list one and not list two. We can just say if not list one, return list two. This will be null pointer, right? Potentially, if they're both null, that's fine. Or list two will have nodes, and that's what we want to return. So then there's also the other case, right? So if not list two, then we can return list one. Okay, at that point, we're going to want to actually get on with the merge, right? So we need a list node or a pointer to a list node. We'll say temp and we'll say new list node. This will be like just an extra list node we need to keep track of the head of the combined list, right? For the like end of the problem for what we need to return. So at the very end, I'll just say return, let's see, return temp next, right? We also need a pointer to a list node that I'll just call combined. At first, it'll point to that dummy node, but that's the one we'll use to iterate. And we're just going to say while list one and list two, right? So while both of those still have list nodes, then what we can say is, okay, if list one, and it's the value of that list node. So if list one node's value is less than list two node's value, right? And we can safely do this check because we know both of list one and list two are not null, right? So we can safely do that. If list one is less, that's the one we want to add to our combined list next, right? So we're going to say combined next. We're going to point that to list one, and then we can go down the list for list one, right? So to the next element. So we'll say list one is going to be then equal to list one next, just to move down the list, right? And then the other case here is literally just the opposite, right? So otherwise list two is going to be less or it's going to be equal. In both cases, we will add the list two node to the combined list, and then we'll shift down list two. We'll go down that list. The next thing we want to do is move down our combined list. So to do that, we'll say combined equals combined next, and that'll move down our combined list. Let's see. Now there's one more thing, right? So there's a chance that list one has nodes and list two does not, right? So in that case, we would say if list one then we want to point combined next to list one, right? And then the other case, right? If we have list two, then we can say combined next is equal to list two, right? And this is fine even if list two is actually null, because this would really just be like a no op. But this is pretty much the code. This handles like every single edge case that you can encounter here. Else if looks like we have a syntax error. So let's fix that and any others. Okay, that looks like it's it though. So yeah, hopefully this helps, and I'll see you guys in the next piece.